Ever since MySQL was a thing, there's been one single driving question. How do we make it go faster? It's a question that has literally defined the success of so many apps and businesses. So today, we're going to trace that story of speed, right from the very first tools all the way to the rise of intelligent automation.
So, to really get why this is so important, just look at this. It's a perfect example. On the left, you've got a query hitting a huge table, 10 million rows. Without an index, the database has to scan every single one. It's painfully slow. Now look at the right. Same query, same table, but with one simple change. We added an index. And boom, the result is instant. That massive difference is the core problem we're diving into today.
Okay, so how did the early MySQL developers even begin to tackle this? Well, they started building out a toolkit, the very first foundational pieces for database performance. Let's dig into what they came up with.
And it all starts right here with the primary index, which you probably know as the primary key. Just think of it like a unique ID for every single row of data. Because it's unique, it gives you the absolute fastest way to find one specific record. This was really the first and most powerful tool in the entire toolbox.
But what happens if you don't know that unique ID, right? What if you need to find, say, all the users who live in a particular city? Well, that's exactly where secondary indexes come in. They let you build these fast lookup paths on other columns, giving you that same lightning-fast performance even when you're not using the primary key.
So as applications got more complex, guess what? The queries got more complex too. All of a sudden, you weren't just looking for a user by their city, but maybe by their city and their last name. This is where composite indexes became so important. By basically combining multiple columns into one index, they made these much more specific lookups incredibly fast. Okay, this next one, this was a really clever innovation, a covering index. The idea is that the index itself contains all the data your query actually needs. And why is that such a big deal? Because it means the database doesn't even have to touch the main table. Everything it needs is right there in the index, which is way smaller and way faster to read. This was a huge win for cutting down on disk access time. So with this basic toolkit, developers suddenly had some serious firepower. Fast lookups were pretty much solved thanks to primary and secondary indexes. Those tricky multi-column queries were handled by composite indexes. And with covering indexes, a lot of the common queries got faster than ever before. The foundation for real performance was officially in place.
But this is where the story takes a really crucial turn. See, the burden of performance couldn't just be on the developer to figure everything out. The database itself had to start getting smarter. And this was a huge shift, moving away from developers manually tuning everything toward the database making intelligent decisions all on its own.
And the way developers could talk to this new database intelligence was through the explain command. As the slide says, it really did become their compass. It let you ask the database, hey, how are you planning to run this query? And it would give you back this detailed map showing you exactly what it was thinking. That insight was absolutely key to helping guide the optimizer.
This timeline really puts the whole journey into perspective. You can see that clear evolution, right? From the simple power of primary keys back in the 90s, moving through these more sophisticated index types, and then into this whole new era of database intelligence with tools like histograms and invisible indexes, which we're about to get into right now.
These more modern tools gave everyone, both the developers and the optimizer, so much more precision. Histograms, for example, gave the optimizer a much better understanding of how your data is actually distributed. This helps it make much smarter guesses about how many rows a query might return, leading to better plans. And when you have invisible indexes, which are like a performance safety net, they let you test out a new index in production without actually affecting any live queries. Super useful. And all of this work led to an optimizer that could handle the insane complexity of modern applications. It could look at a query with tons of joins and subqueries, calculate the cost of all the different ways it could run it, and then automatically pick the cheapest, most efficient path. This cost-based intelligence was a total game changer. So after this whole journey, from these simple keys all the way to a super sophisticated, intelligent optimizer, a fundamental truth about performance really started to become crystal clear. And honestly, it wasn't what most people thought it was at first. And there it is, the big secret. Speed isn't just about throwing more money at the problem with faster hardware or more RAM. It's about thoughtful design. It's about understanding how your data and your queries work together and then building the right structures, the right indexes to support them from the very beginning.
So what can we pull from this whole history of innovation? What are the big lessons? Well, it really shines a light on this crucial relationship, this partnership between the developer who's writing the code and the database that's running it.
Let's just quickly recap the big takeaways. First, indexes are and always have been the absolute foundation of good query performance, period. More advanced indexes, like composite and covering, are your secret weapons for taming complexity. Your explain plan is your best friend. It lets you see what's going on. And you have to remember, the database's intelligence is always evolving. But the most important lesson of all, performance is a partnership. It's a team effort.
And all of this leaves us with one final, really important question to think about. The MySQL optimizer today is smarter than it has ever been. It can make incredibly complex decisions all by itself. So as the database just keeps getting smarter, what does that mean for our role as developers? In this new world, what does it really mean to be a smart developer?